Hi all. So let's take a look at a example of method of sections from chapter 6. So when you're given method of sections, here's the steps that you typically would take to solve for it. If necessary, I didn't write that here, but if necessary, find global equilibrium. You may or may not have to have it depending upon the piece that you're going to use. You're going to cut through the truss members at the members of interest. Now, you can't cut through more than three. Why can't you cut through more than three? Because we're doing now solid body equilibrium, right? So we have three uh, equations, some of the forces in the x, some of the forces in the y, and a moment equation. So you can't have more than three that you slice through at a time because you only got three equations. You can draw your free body diagram of the easiest side and then solve, right? Sounds simple. So here's an example. So we got this thing hanging on the side of the wall, this truss. There's a 9, a 6, and a 3 kilonewton load at points B, C, and D. There is a pin at point A, and there is a roller at point G, right? So at A, you've got an AX and an AY reaction. You've got a GX. It's in the X direction because it's a normal force and because of the orientation of the truss in this particular case. And the question asks us to find the forces in members BC, BE, and FE. You notice those are essentially in the middle, and then tell us if they're in tension or compression. So step one, right, was to find global equilibrium if needed. Well, in this case, when we slice this thing down the middle, I'm going to say we're going to pick the right-hand side, so we don't have to worry about global equilibrium. So we can skip that step. Right, step two is to take and highlight those members and cut. So those are the three members that we're going to be cutting through. We're going to cut through it. And if you remember, step three was to draw the free body diagram of the easiest side. So there you go. We've got the three forces, Fe, Be, and Bc. And we've got the two remaining forces that are external forces, 6 kilonewtons and 3 kilonewtons applied to it. And I've got the angles based upon the measurements from the first part of the example. So what are we going to do? Well, I mentioned this in the chapter 6 overview. You will usually want to start with a moment equation, and sometimes you do more than one moment equation. This is one of those examples where I'm going to do that. So I'm going to do two moment equations. The first one I'm going to do at point E, and the second one I'm going to do at point B. So when I do the first one at point E, you notice that BE and FE will fall out of the equation, and I'll only have BC left. And actually, the 6 kilonewtons will also fall out because those forces all go through point E. When I do point B, right, BC and BE will fall out. I'll be left with just FE, and the 6 and the 3 will still be there, and I'll be able to solve for FE in that case. So let's move ahead. And there's the first part. So when I take the moment at point E, right, I've got BC and I've got the 3 kilonewton force. Right, those are the only two things I have. So we find that BC comes out to 3 kilonewtons, comes out to a positive number. If you noticed on my free body diagram, I assumed it was in tension. Since I got a positive number, still in tension. Right, so for the moment at B, the 6 and the 3 have a contribution, and the FE has a contribution, right? BE, BC fall out. Well, FE has a X and a Y piece, so I got to count for both the X and the Y piece because they both have a moment at point B. So I plug all that information in the equation, I get minus 9.49 kilonewtons. Negative sign tells me that I assumed the wrong direction, so it's not in tension, it's actually in compression. Last but not least, I applied my equations of equilibrium in the X direction. All right, so the 6 kilonewton and the 3 kilonewton piece are both in the Y direction, so those are gone. So all I have are, as you see here in my equation, I got BC, I've got a X piece of FE, which I've already solved for both BC and FE, right? And I've got a X piece for BE. So I can plug in those numbers that I previously solved for, solve for BE. I find that BE comes out to 12.74 kilonewtons, positive answer, so it is in tension as I assumed at the beginning. So there you go. there is a example of doing method of sections from chapter 6.